Okay, ma'am.
Yes, so welcome to the next session. This session is on introduction to Open LCA software. Our speaker is Mr. Srirang Booth, who is Chief Regulatory Officer at Eurocentric Chemicals Private Limited, Whole India Group Company. Mr. Booth has done his master's in Environmental Science and Engineering from Indian Institute of Technology, Delhi. He is also a certified chartered environmentalist from the Institute of Environmental Science UK and the Society of Environment UK. He has over 19 years of experience in the regulatory compliance field, and currently he is working in the capacity of Chief Regulatory Officer at Eurocentric Chemicals Private Limited. As the name suggests, he works towards the all compliance related requirements for the group of companies. His primary responsibility involves developing and implementing the procedures as per the regulatory requirements towards sustainable chemical management. He is involved in sustainable chemical management approach through chemical regulations like EU REACH, K REACH, EU BPR, AP 891, ROHS, etc. He is involved in sustainability and LCA activities for the industry. He is also involved in developing solutions within various global regulation as per their respective compliance requirement. After thoroughly studying each regulation and its compliance requirements, keeping up to date information related to regulatory developments in the field of chemicals and guiding the company as well as the supplier from time to time. So there cannot be a best speaker than Mr. Srirang Booth for let us understand the LCA. I mean, whatever we have been listening in morning or before that about WLCA, he is the one who is going to tell us about how to do it, right?
Yes.
Srirang? Yes. So we are eagerly waiting for this,
Yeah.
and now I hand over the session to you.
Sure. Thank you. Thank you very much, ma'am. Thank you for the
Just
introduction.
a small note
Yes.
that sometimes participant type their questions in the chat, so please
Yes.
keep an eye on that.
Okay. Sure. Sure. Thanks. Uh, so very good afternoon, everyone. Thank you, Vedi ma'am, for the introduction. And let me share my screen first, and then we can go for the session. Please let me know once you can see my screen.
Yes, sir.
Yes, sir.
Okay.
Yes, sir. Yes, sir.
So sorry. Yeah. So very good afternoon, everyone. And I managed to attend the morning session, and then I thought that I missed the previous session because it was really interesting to know the things, to further upgrade the knowledge that we do the activities daily on LCA. And LCA is it's a tremendously huge topic to discover. So it's very interesting to deep dive into those kind of discussions from the experts. So I'm really happy that I managed to attend the morning session, but I'm sad on the other mode that I missed the previous session, but it's okay. Uh, so today, what I'm going to talk about is because you are hearing LCA a lot during couple of days, and I thought it is best that you should also have an hands-on, like you should be able to see at least one of the software, like how it looks, how it does the calculation and all. So this session has been arranged, and thank you to Dr. Rahul Ralegaonkar sir for giving me this opportunity to present the software. But before going into the software, I thought there should be a couple of things that I need to tell you about the background. And it could be something can be repetitive, but it is good to repeat the things so that you have better understanding, because then you have a perspective from different person to listen to the same concept. So what I'm going to speak today is about, I'm going to give you a brief introduction to LCA, why it is required, how it is performed, and then we will go into the LCA software. So I'm going to show you the Open LCA software, how it looks, and then we can also have a small demo hands-on, like how it works. And I have a small case study which I want to show you, like how we can run the software. So everybody knows now that life cycle assessment refers to the systemic method of assessing the environmental impacts of a product, of a process, of a service at all stages of its life cycle. So life cycle analysis can be from cradle to grave, that is from starting till end, or it can also be from gate to gate. I mean, we can limit the scope of assessment, because if you start, if you want to do a cradle to grave analysis, it has a huge network or PCRs involved into it. So to simplify it, when we are going into the example, I will be doing gate to gate analysis to show you like how one activity, how we can do the LCA for one activity, and same kind of an activity needs to be further performed into different categories, and that can be connected together to get a complete cradle to grave analysis. So what can be done with the LCA is basically it is used mainly for the product or the project development. It is also used in strategic planning, and it is also used in public policy making. So how it is going to help is basically when you do an LCA, you get to know like which are the steps or which are the processes which involve which has comparatively higher environmental impacts compared to the routine process. And then we can see how can we optimize those processes so that the environmental impact can be controlled. And yes, this is where the strategic planning comes while developing a project or while developing a product. And obviously, these LCAs can further be used by the policymakers while deciding the some regulatory limits, where we can like we may have in future that there could be a limit for this particular activity. There could be a limiting value of carbon emission or GWP. That's a future as of now, but since it's booming, it's growing, so we can use as of now to generate the data. You can use a you can see the data how it develops. So how a product life cycle looks. So this is how the product life cycle look, where it starts with the raw material acquisition, material processing, manufacture and assembly, use service, retirement and recovery, and obviously the treatment disposal. So product goes into all different kinds of stages where there is material and energy goes as an input, and obviously at every stage the waste comes out in the form of gas, liquid, or solid. So either we do the analysis of individual stages, or we do the analysis of combined uh, cycle. So if we are talking about a product life cycle, we can talk about starting with raw material acquisition till the final disposal of the product into the waste or into the landfill. Or we can simply talk about only the life I mean the assessment of manufacture and assembly stage. Or we can also do the assessment at the material processing stage, or even at the use and service stage only. So when we do the analysis at the manufacture and assembly stage, that is called as gate-to-gate analysis. But when we do the analysis from raw material till final treatment disposal, it will be termed as cradle-to-grave analysis. Why it is required? It is important to know why we are doing this life cycle assessment. So basically, it will help to identify the environmental impact across all stages. Obviously, it will include the energy use, greenhouse gas emission, water and other resource consumption, waste generation, air and water pollution. Everything can be assessed with the life cycle analysis. This assessment will give us to take the informed decisions, like choosing between the alternative materials, improving the product design, selecting more sustainable suppliers, or reducing the carbon and water footprints. So once we do the analysis, obviously it will help us to do the informed decisions. It also help us to promote the sustainability, encouraging the eco design, recycling and reuse, and waste minimization techniques. It also further support certifications and declarations like EPDs we have seen in the morning, which gives I mean, it's not as of now, it's not comes within the regulation, but it's a proactive approach to further uh, do the branding of the company or branding of the product. And then obviously there are regulatory compliances like EU Green Deal, REACH. It's a regulation in the chemical industry, and then obviously ISO standards, that is 14040 and 14044, which describes the framework as well as the procedures involved into the life cycle assessment. We have seen the different ISO standards in the previous discussions when Dr. Anil was presenting, when his focus was on more on EPD, but now the focus is I am limiting my focus to the life cycle assessment part only, where we will be doing the environmental impact reporting, green public procurement, or product environmental footprint. So for that, the framework stands with 14040, and the procedures are given in ISO 14044. And then obviously it gives the competitive advantage, like companies can use the LCA to demonstrate their environmental responsibility. It can also be used in differentiating the eco-friendliness of the product. And obviously now the consumers are demanding for the sustainable goods, so this gives an opportunity. When the product LCA has been made, it has been presented in the form of EPD or carbon labels, then obviously it gives a competitive advantage compared to the other industry in the same product group. Now moving further, how it is done. So as I told you before, ISO 14040 talks about the framework, which informs about defining the goal and scope, life cycle inventory, life cycle impact assessment, and the interpretation of the results. So at every stage, interpretations is mandatory. So you can see from the graph, it is clear that when I'm defining the goal and scope of my assessment, uh, I'm fixing where I'm going to do the analysis, whether it is a cradle to grave analysis or whether it is a gate to gate analysis. Depending upon my scope and goal, then I went to life cycle inventory. So I need to collect the data for doing the impact assessment. And then obviously doing actual impact assessment. So there are several methods or several methodologies which are available as of now in the market, which has been developed by government agencies. So those assessment methods will help us to decide what kind of and results we are looking at. And then every stage we have to do the interpretation, and after doing the assessment we have to do the interpretation to present the results of the assessment which we have done for the product. So there are several softwares which can be used for LCA. I have listed here a couple of them, like OpenLCA is the software, Gabi, Sima Pro, EcoChain, OneClick LCA, Umberto. So there are n number of softwares available, but these softwares are the paid softwares like Gabi, Sima Pro, EcoChain, OneClick LCA. These are the commercial softwares. They are little expensive, but when we are talking about an academic example, I thought to go with an OpenLCA, which is a free software which can be freely downloaded and it can be easily used. So that is what I'm going to show you, how it can be easily downloaded and how it can be used. But yes, there are several professional softwares are also available in the market which can be used, and mostly the industry is using the paid software because they have different kind of requirements within their uh, group. Now coming to the databases, we also heard about the databases in the previous session. It is very important to have the background data while doing the assessment. So there are standard databases which are available. These are a couple of examples which I have listed down here. So there is an EcoInvent database, which is a European database, which is a very good quality database. Gabi has their own commercial database, which can be used through their software. OpenLC and Nexus is the platform where you can get or you can buy the databases. So there are databases which can be freely available again, but not all databases are freely available. You have to pay for getting an access to the database while doing the life cycle assessment. So I'm going to show you like how you can get a couple of free databases to do your life cycle assessment, at least to practice while doing the life cycle assessment. And then obviously after databases, which gives the inventory details, we have to go to the impact assessment method. So there are several impact assessment which has been developed since 1999. Like you can see eco indicator 99, which is one of the oldest uh, assessment method. But my favorite is recipe. Recipe method is the method developed by European Union. Uh, it can be used globally, and it covers basically midpoint and endpoint analysis. So when we do the impact assessment, we come up with the data. So you have heard about the GWP, that is greenhouse gas uh, equivalent or CO2 equivalent values. So that is a midpoint value. So it gives an average of the data which has been collected for that particular activity. Whereas there could be an data when we talk about like human health hazard effect, or where we are talking about ecological effect, or we are talking about the resource scarcity related effect. So those effects are basically the endpoint effect, when actually the effect or the product is used eventually to give that effect. So that's why it is called endpoint effect, and the midpoints are basically are the effect which are like brought up at the middle of the activity, and those are the best compared to the endpoint effect. But yes, both these midpoint as well as endpoint effects can be used while doing the impact assessment and to interpret the data. So there is a Tracy database which is also commonly used for doing the LCA analysis, which is a US based LCA for the US based LCA studies, and Recipe is the EU based LCA studies. These are the two more popular impact assessment methods which has been globally used as of now, but there are several others. So now coming to the Tracy method, which is the US developed method, it gives the impact into different categories. Like it gives the impact of ozone depletion, it gives the impact in climate change, acidification, eutrophication, smoke formation, human health impacts, and ecotoxicity impacts. So there are 7 to 8 categories which we get from Tracy impact assessment method. Whereas when we go into the recipe method, I hope my slide is visible. So there are actually total 17 points where you get the values for the impact categories. So you can see this is the list of endpoints or the impact categories, which can further give like what are the damage pathways. And basically these all 17 points can be further trickled down to 3 impact levels: damage to human health, damage to ecosystem, and damage to resource availability. So these damage to human health, ecosystem, and resource availability are basically endpoint effect. But when we talk about the midpoint impact categories, then you can see the number of endpoints which we can get using the recipe impact assessment method. So basically recipe impact assessment method is developed in 2008 in Europe, but it has been further upgraded, and recipe 2016 midpoint is the uh, most advanced, most developed impact assessment method currently is in use while doing the LC analysis. Now, moving to the OpenLCA software. So it's a open source software for lifecycle assessment. It has been developed by the Green Delta company, which supports the lifecycle assessment, carbon footprinting, EPDs, and social LCs. So this software can be used while getting the LC analysis, but you can also generate your EPDs while using this software. Why it should be used? Because it's free and open source. It supports multiple LC databases. It's transparent, customizable, and it's extensible and scriptable. So you can add scripts to this database, you can add formulas to this database while doing your assessment, when we go inside the software, I will be better show you some examples how we can do these kind of an activities into the OpenLCA software. So these are my slides, but I think now we should go to the website where I can show you like how you can download the software. So it's very simple. You have to go to Google, type OpenLCA. The first link which you can see, you have to open that link. So this is the OpenLCA website from where you can download the software. These are the different services that you can get. They also provide trainings, tailor-made supports. There are certified trainers who are available to do the third-party assessments as well. So there are n number of services which you can get, but as of now, we will just go into the download button. Here we can click on the download, and then there are a couple of details they ask. If you have to fill in these details to download the software. If you don't want to fill in the details, there is a link, take me to the download page. You can just click on here, and here you get the software. So this software is available for installation into Windows, Mac OS, Linux, and other operating systems as well. So normally everybody has a Windows, so it is recommended that you use this installer. So currently there is OpenLCA 2.4.1, which is the current version of OpenLCA which is available. So you can directly click here and just download the file and install it. If you have older versions of LCA and if you want to keep this version as a separate, then you should download this zip archive folder, which will help you to maintain different version of softwares within your PC. So when you have to use different versions, use this. Otherwise, if you are a first time user, you can directly download this installer and install it. There are a couple of next buttons you have to click, and then the software will be installed. Now, so once the software is installed, can you see my desktop now? So this is how the home page of OpenLCA software looks like. And on the left hand side, you can see there is a navigation plane where you can navigate into the software. So what basically you need is you need the databases. So when you need a database, you need to right click on this navigation place, and then you can create a new database. So when you create a new database, it will be an empty database because you don't have any background data for your own LCAs. So either when you're creating a database, you should have your own values to include into the background activities to perform the LCA. But if you want to use the standard databases to do the LCA, that's also possible. So if you have to create a new database, you can just type here, and then I choose this complete reference data and click on finish. So it takes a while, and then it creates a database. So you can see that this test database has been created, and here you can see the impact assessment methods. Everything is empty. Now there is nothing here because this is your own database. So now you have to feed in the information here. So either you create your impact assessment method or you import the impact assessment method, or better go for a standard database. So when you are doing a trial, when you are doing a demo, I would recommend that you should go for a standard database. So now we again go back to the OpenLCA software, and then we check what all databases are available. So we can go into this data, and then you can see it is directing us to the different website. This website is called as OpenLCA Nexus. So we click here on the browse databases, and now you can see that Open Nexus website has opened. Here you can see there are n number of databases which are already existing in the market which can be used for doing the life cycle assessment. Okay, and here you can see their details also. So like for example, EcoInvent, it is one of the most famous LCA database in the world, used by more than 5,000 organizations worldwide. And then they have how many entries, how many details, how many cutoff values, everything is mentioned here. Now from this website you can also see what are the free databases which are available and what are the purchase databases which are available. So free databases, you can see already there's environmental footprint database from European Union, which is freely downloadable. But when we go into the purchase database, there is a, I like this database because I have also used EcoInvent database a lot. There is a possibility that we can get this database for free. So you have to go into the EcoInvent database and you have to scroll down. So you can see the commercial single user license cost is 3,800 euros. Okay, so you have to go down a bit, and there is one educational multi-user database which is available. It's only for educational purpose, uh, for the users in low and low middle income countries. So here we have to see if our country falls within this. And then obviously there are impact assessment methods also available, LCIA. So life cycle impact assessment methods are also available. So either we can download methods only, or we can download the complete data set from here. For this, you have to then obviously register to this website. Then you have to log in with your username and password, and then you have to process it. So it's not a quick one-click activity, because they verify the user, they verify which country you belong to, and then they give an access to you the databases. So I have done that activity for you to show it on the demo. And you can here see that this is the EcoInvent database which I have downloaded from the website. Now, if I go into the impact assessment methods, so you can see there are two different methods which I have downloaded. One is from OpenLCA methods and one is from EcoInvent method. So either of this, if I expand, so you can see there are n number of methods which are available to do the calculations. Okay. So like we discussed about this Tracy. So this is Tracy 2.1 impact assessment method is available. Same time recipe method is also available. So we have to go with the recipe midpoint H when doing an impact assessment for any product. So before going into the impact assessment, first we need to create a flow within the life cycle, within the product life cycle, and we have to also create a process based on the flow activity. So here I would like to take you with an example. I have done a small example where I have collected a data where we want to do a life cycle assessment for concrete mixing activity. So here we are just doing a concrete mix, which is for 1 cubic meter concrete, which is approximately 2,400 kgs. So I have collected this data. It's not exact data; it's a random data, just to give you an idea how it works. So this is my inventory where I have collected what all ingredients which will be going into the mixing activity. So obviously it has cement, it has fly ash, it has sand, it has aggregates, it has fiber, it has water. And then obviously the mixer also uses the electricity. So this is the input data which I will be needing for doing the concrete mixing activity. And what is the output is basically I get a output of concrete mix of approximately 1 meter cube, which is equivalent to 2,400 kgs of the concrete. So this is my basic inventory which I have done before doing the life cycle assessment. Now I go into actual actually doing the process. So this is the process. So we have to right click on it and click on the creating a new process. So obviously I have to create a new process for concrete mixing. I've mentioned it as a test data because this is just a demo. And it's not a waste treatment process. And I want to create a new flow for this. So because I don't have a flow for this concrete mixing activity available. So I create a new flow. The new flow name, I keep it is same as it is. And obviously the reference of the flow property is mass. Basically we are talking about the quantity of concrete which will be generated. So we are going to deal with mass. If it depends like what is the activity for which you are creating a process. So there could be a process where you are just creating for energy. There could be a process when you are creating for a building, then you will have the reference flow property as area. But here we are just creating a concrete mix which has a reference flow property as mass. So we are going to measure it everything in mass. So I keep the reference flow property as mass and click on the finish button. So once I create a process flow, you can see the name appears. I can write down the description about like how the mixing process is going to happen, what all details will be covered. That's up to me to add the information. The more information I add here, the more information I get into the report when I generate the final life cycle assessment report. Then obviously start time, end time is available because it's it's not a one time activity that I just start and I finish. Actually, when you do the life cycle assessment for a gate to gate activity or even for cradle to grave activity, it's a long term activity. It takes almost like 15 days, 30 days, and sometimes months time to do the life cycle assessment. So one should know like what was the start date and what was the end date, how much time I took for doing this kind of activity. It keeps a record of it. uh, then obviously we can also add the location where this concrete activity is based out of, which technology which we have used, and we also mention about like the uh, data quality, how the flow quality which we are going to use. Next to this general information, you can see here there is called input output details. So now you can see the input flows, like what are the input activities that I'm going to do, what are the input ingredients that I'm going to put into this activity, and what is the output that I'm to get. So this is the flow for production. Okay, so you can see that this is the concrete mixing is the output, and the amount is in kgs. So this unit is fixed based upon the flow measuring unit which we have selected while creating the process. Now I need to start adding the flow. I mean, I need to add the values. So we want cement here. So since I have imported the EcoInvent database, I already can add a flow here, and then I can just type down cement. Which cement? So I need a cement, obviously. So it has to be a Portland cement, which I'm using. And then obviously I need to write down the quantity, which is 30 kgs. If I have, I mean, I want to do the cost analysis also, along with the life cycle assessment, I need to add the cost values here. Here, and then I can select which currency I want to do the analysis, and then obviously I have to add the cost. Then it also gives the cost analysis part. We have to also see who is the provider. So you can see this is the standard database which I have downloaded. It's a US based database, so we don't have a background information. So it's basically a cement production. So as of now, I'm selecting this provider for the Portland cement, and right click, create new. Fly ash. So fly ash normally I choose from the elementary flows. So these are the elementary flows. So fly ash comes from waste. So that's why I've chosen fly ash from here as 300 kgs. Then we have sand aggregates. Then we have sand. Then we have to add sometimes they don't. So again, aggregates. I choose 6. Then I add fiber, cotton fiber here, 1 kg, and then water. Water again, I take it from resources. And then the water values from different locations are available from the database. So it's river water. Yes. I guess somebody wants to ask a question. Hello. Yes. Some
Sir, it is in
Sukhanandi.
the chat box. Yes.
Yeah, Sukhanandi has raised her hand. That's right.
So chat box, she has typed her question.
No, this is not automatically available. Here it is automatically available because I'm using the standard database. So I have downloaded the database. You can see here the eco invent database I'm using. That's why it is automatically available. If you create your own database, you have to first create all these processes for uh, cement, sand, and fiber. Elementary flows you can easily get, like natural aggregate, water, river, fly ash, you get easily. But for cement, sand, and cotton fibers, you need to create the processes first when you want to generate your own life cycle. Here I'm getting it directly because I'm using it from the database of EcoInvent, so that it's easy for me to show you into this demo. I know it's not easy. I mean, it's tough to get these values. It's tough to get the correct flows to reach to the particular assessment. And okay, so now the final output is of 2,400 kgs amount. If I sum up this amount, it should give me this kind of an concrete mix amount. But additionally, there is one more unit which is electricity used in mixing. So we have to add here electricity also. So electricity, medium voltage, and we need 2 mJ of electricity. So here it's a couple of basic things which I have incorporated for showing you the demonstration. So you have given all the inputs, you have also given the output. Then you can add some administrative information like what is the intended application, who is the set owner, who is the data generator. You can access and you can mention about the use restrictions you don't want to disclose. If you want to claim a copyright on your own database, you can create a copyright here. And then there are several other like modeling information, which LCI methods you are going to use, which modeling constants, data completeness, data selection. This you have to write down when you are like developing a detailed LCA analysis for a particular process. So once everything is done, you again go back to the general information, and then can you see this? There is a small star mark here. It is because now I haven't saved this activity, whatever activity I have done. So I go here on the left hand side corner, I click on the save button, and then that star mark is gone. Okay, so now my activity or my process is saved, and I want to see like how can I do the impact analysis of whatever activities I have incorporated. So either I can create a product system first. So real process is to write down the flows, then go to process, and then go to product system. But since we want to use the flows from the database, we have directly gone into process, and from process we can go into product system. So we click on here, like we create a product system, and this is the flow which has been selected. I mean, auto link process is the recommended one. Preferred process type, I want the analysis of this unit process to be done. That's why I have selected the unit process, and then I click on finish. So it creates a product system from the process. Okay. So now here we are here at the product system. Can you see this concrete mixing test? And then here you can see the model graph. So this is the concrete mixing activity where I'm going to, this is the input flow and this is the output flow. Because this is a single activity, model graph is just a box. If I include n number of process, considering the transport activity, considering the raw material procurement, considering the pre-treatment activities, then obviously this model graph will expand further. Now I have to see to do the calculation for impact assessment. So now I will choose the impact assessment method as my favorite one, the recipe 2016. I want to assess the data quality. See, include cost calculation option is also available, but I cannot do that because we haven't added the cost. If we have the cost details, we can further include the cost calculations into the lifecycle assessment. Then you can see that flow schema is already eco-invent data quality system, which has been selected because we are using the eco-invent data quality system. And the aggregation type is weighted average. I click on finish here. And here I get the values. So this is the general information which informs that there is a target amount of 2400 kgs of concrete mixing. Impact assessment method is used as recipe. The flow schema is eco-invent, and then these are the results for the impact categories. So there are several impact categories, like I told, 17 impact categories within a recipe method. So you have to go into each drop down to see what is the value for global warming, and here you can see what is the uh, activity, that the clinker production is the highest contributing activity in the process, which is contributing uh, towards our impact assessment as well. And you can go to the impact analysis, this drop down, and here are the values for all the 17 categories of the open LCA software. So like global warming potential value is this, that is 310 kg of CO2 equivalent. So either we can uh, download this values, we can copy paste into Excel if you want to plot, or we can directly plot. You can get a plot here also. So here we get the plot for individual categories, like this is for marine toxicity, this is for ozone formation for human health, this is for water consumption. So all graphs you get individually, and this is the overall impact analysis for that concrete mixing activity. If you expand this, then you will get to know like what is the contributing activity to arrive to this impact assessment value of 310. And this can further like we can go into projects where we can like do multiple uh, product analysis, and we do the comparative analysis into the project. So if we go to project, this is just a demo I have. I just want to show you that. And if I calculate the project report, I can show you the different kind of mixes I have compared, and then you get the values for all these three different kind of mixes which I have analyzed. And then if you click on the report, then you get this kind of a report with all the values and the graph. So this is the relative graph compared to for all the three products. So these are the three different mixes which I have compared here. But here I can also get individual values for them. So what is the which is the mix which is contributing towards more? So this gives a comparative analysis when we go for a project report into the OpenLCA software. So I know it's difficult to tell the complete software in this 1 hour time, but this is the basic I thought I should share with you. And if you have any questions, I'm open for the discussions. That's all from my side as of now. Thank you.
So, sir, I want to ask one question.
Yes.
Because since 2 days, Professor Sani has been discussing whole life cycle assessment and all.
Yes.
What I have seen is there are some softwares which are not open source softwares,
Yes.
I just want to know that if we use an open LCA and if we can use a different software which is not accessible to everyone,
Hmm.
what will be the effect in the result which we are getting out of the two?
Yeah, it's a good question. Actually, it's a challenging activity. There is no one as of now where you can get the standard result. Like if I do the LCA by myself, you will get a different value, and if you do the LCA by yourself, you might get a different value. So it varies from the person to person, it varies from software to software. So but yet the results are acceptable, and we have to see when we are using an open LCA software, we can what we can do is that we can try with different impact assessment methods to check if the values are within the range. If the values are not much varying, then those results can also be accepted while presenting the report. But as yes, I agree, the values varies with the inventories, values varies with the background data which is available for doing the life cycle assessment.
Okay. So if I want to do some assessment in the real life case study,
Yes,
will Open LCA give me a I mean acceptable answer?
yes,
That is what you are suggesting, right?
yes, yes,
So I can use this not only for the research purpose, but
yes,
for the actual assessment of a project.
absolutely, absolutely, you can use this.
I will be able to do it.
Yes.
So the database which is it is giving,
Hmm.
for example, you were showing it for the cement
Yes,
and concrete.
yes,
So because you took a I mean sample project,
yes.
what all data I have to keep ready before I start with this project?
uh, there are n number of entries which are actually required because there is no database for India as a
Yes,
state.
yes.
So for making the data for India is a challenge. That is what we are working, but that is what we are discussing also. Uh, what background data we can generate or gather to support the actual LCA from the Indian perspective. But we can use these key values which we got from this eco invent. I am also discussing one of the professor who is based out of Netherlands in Delft University, who is helping me to. I mean, he has given me the structure and the framework for collecting the database, which is into Excel format, which we can collect that information and then we will be able to use it. I can share that information with you, ma'am.
Okay. And in the morning session, Professor Sani was discussing that there are some open, I mean, EPD thing we can get in,
Yes,
and they will be generating. There we can generate some files which we can directly pull into the software.
yes.
So,
So
will Open LCA give that compatibility?
yes, yes. OpenLC also once you have done this life cycle analysis, which I have shown, once you have created, once you have reached to that product, I mean, product system. Once you are into product system, that product system you can call into the EPD. There is one more tag I can show you. Just a second.
Yes, I mean by
I
this we
mean,
will
yes,
be
I
able
can
to
connect that
connect.
EPD also. Just a second. I
Yes,
just
we'll be able to connect the two things which we have seen in morning and
yes, yes. So I hope you can see my screen now.
yes, we can see.
Yes. Okay. So you can see this database. This is product system, projects, product system, process, flows, and then there is an EPD's options. So here it's an EPD options where you can create test EPD. I mean, just right click on it, new EPD, write down the name of the EPD which you want to create. Okay. Then obviously you have to tell who is the operator, what are the PCRs that you have used. These are from the standard database, and then you have to add the modules. So like A1, A2, A3, which you discuss in the morning, and then you can add further A4, and then and so on. So once you start adding the modules, uh, you have to connect your flow here, and then you can generate EPDs also.
Okay.
So there is a possibility to create EPDs using the Open LCA directly, wherein you can create a report. These EPDs can further be connected into projects. You have to generate the report, get that PDF file, and then we have to further revise it with the help of experts, and we have to get it validated before putting it or presenting it into the market.
Okay.
But because of the time constraint, I mean, it's difficult to show them. There are n number of things that can happen with the software.
Yes. No, no. I mean, I am not sure, but we have still more, some 15 minutes more to conclude actually.
Okay.
So if there is something which you can throw light on, we are still there.
Okay.
And there are a couple of questions in the chat section.
Yes.
Pardon, Bhageshri?
Yes, I'm into chat section now, Bhageshri.
Okay.
Ah, yes, there are specific questions from this.
Yes. Now coming to the question, we can use other supplementary cementitious material like rice husk, GGBS, bagasse, etc. Yes, you can use, and that I mean, first you need to check whether you have the flows available for that particular material, and if yes, then we can directly call that like GGBS. I know that there is already a flow available which you can directly call from the database to include into the process, then which can further use for doing the assessment. The endpoint impact assessment, coming to the endpoint impact assessment, is basically human health hazard, ecological hazard. I mean, the value which you get for human toxicity, the value you get for ecotoxicity, and the value or ecological toxicity, and the value which you get for the mineral scarcity. Those values are basically the uh, endpoint impacts. Those values can be interpreted while writing the report as an endpoint impacts. And there are no databases which are Indian specific as on date. uh, there is a lot of discussion going on, but there is no standard published database which I have seen for the Indian specific. uh, Mostly the data is available from the developed countries like US and European countries who has been contributing. But if India as we join together for generating and developing the database, then it will be very easy. But working with the industry, Indian industry, it is very difficult. They are not very open to share their data, and they are very conservative. So it's difficult as of now from the Indian perspective, but yes, we can work together so that we can have our own database. And whenever there is flow not available uh, for your particular activity, yes, you can create your flow. You have to have background data for your flow. You can create a flow, and then you can connect that flow to that respective process. There is no Indian specifications available, but I mean, as of now, I am also working on this kind of an activity where we can gather the database for India. So first we need to see like what format we need to generate the data or collate the data. Uh, and then once that format is validated, obviously it will be very interesting to collect the data from the industry if they can contribute. Industry associations, with my experience, are the best to contribute with the data. But I work with the chemical industry, so chemical industry has their own export promotion council. They have their own industry associations who collate the data from the industry, which is again not in much detail because it's not very environment friendly industry sector, chemical. So they don't want their sector to be presented as a negative sector, because their impact assessment value sometimes goes on the higher level when we go into the chemical manufacturing activities. So there, getting data from industry is a challenge, but let's see how we can uh, help our government to come up with something so that they can push the industry to share the data. But it's not available in the Indian context as on date. And softwares are, I mean, uh, softwares are not experts. Okay, humans are experts. They just do what you give them the command. So don't get hesitant with the software. Go download the software, play with the software. Nothing goes wrong in that when you play with the software, because until and unless you play with it, you won't be able to get a confidence while navigating. You won't be able to understand the uh, respective sections or the processes. And once you are fine with the software, then start reading the technical support. There are n number of technical supports which are available in the software itself, as well as on the web platform, wherein you can collate the information and do the activity. This is a booming sector as on date uh, across the globe, because there are very less LCA experts which are available. So more you get into contact with the experts, discuss with them your problems. And to discuss the problem, first you should be acquainted with the software. You just go to that OpenLCA Nexus website, wherein you get an access to the databases. Try to explore how you can freely download the database, because as I told you, that EcoInvent is not a free database as such, but then you have to go inside it and to see how you can download it. What are the different possible alternative options are available. Uh, but otherwise, Gabi and other softwares are they're little expensive, but they are also much user friendly compared to OpenLCA. You can see that OpenLCA has very uh, tiny letters, tiny fonts. It's very cumbersome and tedious when you start doing a large life cycle analysis. But that's it. I mean, that's open source, so I would prefer to use that and learn as much as possible using that. And as rightly Dr. Anil said, that we should read the EPDs. Once you start reading the EPDs, you will be able to correlate with the impact assessment methods which they have used. Once you know the method, you will get to know what are the outputs that those methods are going to give, and how you can interpret, correlate those values. So you can see the EPDs which are already published and how the companies are presenting those values, and then you can compare your own values with this, uh, with the kind of results that which they got, just to make yourself more comfortable with doing the assessment. But it's just a practice and consistency that you have to follow with the software, with the data, and you will be able to do it. Yeah, so that's all from my side as of now.
Yes. So thank you. I think you took the question from Harshal T as well.
Yes.
Okay. So thank you so much, Srirang sir. It was
Thank you.
really very nice to see the. I mean, and I hope you are there. So whenever we go through the
Yes.
software and you find any difficulty, we'll be able to reach you
Yes,
for
absolutely.
further guidance.
Yes.
Yes. So now there are no more questions from the delegates, and we are well within the
Hmm.
allotted time. So, Manoj,
Yes, ma'am.
Magashi, now we can log off the streaming.
Yes,
Yes.
ma'am.
Thank you, ma'am.
Thank you.
Thank
Okay.
you, everyone. Bye bye. Good day.
So we will join again for the next session. The next session will be
At
on
3:45.
at 3:45. Okay, Mangesh sir.